All right, I want you to have a look through the multiple angle identities. So this is going to be our focus today. Just have a look through there. I want you to see what you notice about those, 10 or 12 identities there. So I would say this kind of splits into two categories of identities. Some of these are double angle identities, and some of them are half angle identities. Are you seeing the double angle identities? The double angle identities are the ones that always say 2 times something. It happens to be theta here, but it could be x or 2 alpha or 2 beta or 2 theta or whatever. And then the half angle identities are the ones where it's something over 2. And again, the fact that this is alpha doesn't mean anything. This could be theta over 2 or x over 2 or whatever. So we got double angle formulas and half angle formulas. Did you notice that some of these are repeated? Like cosine 2 theta. Can you find the cosine 2 theta identity? Did you notice there's actually 3 identities that are all equal to cosine 2 theta? Okay, which one's the right one to use? Situational. Or a lot of the times it doesn't matter. So we're going to do some examples today where we're just going to arbitrarily choose one, meaning it really doesn't matter whether you use the first, second, or third. The only time you really need to choose the correct one when you're using these is if you're trying to do a proof. And usually you'll be able to kind of look at your target and figure out which one's going to get you there. What's the one that's repeated for the half angle? Tangent's repeated for the half angle. Now, my personal preference, if I have my choice, and you usually do, I almost always go with this one because it looks simpler, doesn't it? There's no square root, there's no plus or minus. It's a fraction, but there's only one term in the denominator. This is the simplest one, in my opinion. I'll almost always default to this one, but it really doesn't matter which one you pick. So, all right. So we've seen our double angle identities. There's 5 of them here. Really, there's 3, but there's 3 versions of one of them. So let's do some examples. So this is going to go pretty quick. We're basically doing some substitution here. So we're going to do cosine 2x minus sine of 2x. So let's do this. Let's see what can we substitute in place of these two things. Cosine 2x, I'm looking at my cheat sheet here because I don't have these memorized. This is the one where we have 3 choices. Which one you guys want to do? First, second, third? First? I'm hearing second. I'm hearing third. First? It doesn't matter. Yeah, do whatever you want. I think I did the second one earlier today, so I'm going to go with the first one just to kind of mix it up for myself. But you do whatever you want. So I'm going with the first. This is going to be cosine squared x minus sine squared x. If you, instead of that, used 1 minus 2 sine squared x or 2 cosine squared x minus 1, that's fine. Probably a good idea to put these in parentheses when we're doing it. Although sometimes we don't end up needing them. And then sine 2x has only one option. This one I actually do know because it comes up a lot and it's pretty simple. It's 2 sine x cosine x. But if I had forgotten it, it's right here on my sheet. 2 sine x cosine x. Now the instructions say write in terms of sine x and cosine x, which means any sines that I have can only have an x inside, and any cosines can only have an x inside. Are we done with this then? Let's say, yeah. All of my sines and cosines just have an x inside. There's no 2 x's inside. There's no 3 x's inside. It's all just x's. Some of them are squared, but that's okay. The angle is just the x. So this is it. That's my answer. We could leave it just like this. That's it. Nice. Okay. Do another one. That's it. I think if you looked up the answer in the back of the textbook, they'd probably get rid of the parentheses because they're really not necessary here. Sometimes they'll do some factoring, but if the instructions just say to write in terms of sine x and cosine x, we're done. All right, let's move on to the next one. This next one's going to take a little tiny bit more work, but not much. Look at your pink sheet. Do you see any identities where it's a 3 theta or a 3 alpha or a 3x on there? We see a bunch with 2's. but none with 3s. So what are we going to do with this? I'll give you a hint. We're going to have to use some other identities to make this work. Any ideas? We're going to need to combine some of those double angle identities with some other ones that we've already talked about. What do you think? Sum and difference, yes. Can you rewrite this as the sign of two things being added together? What two things could add together to give you 3x? Yeah, it was 2x and x, right? I'm going to put the 2x first and the x after. If you did x plus 2x, though, that's fine, too. So that's one of our identities where we're adding the two angles. Now, I'm trying to re-memorize these. It's been a while. I think this sine version is the one where it's sine cosine and cosine sine, right? You guys have your sheets in front of me. Mine's covered up right now. I'm pretty sure the sine's the one that's sine something, cosine something, and then the second part's cosine something, sine something. Does that match what you see on your sheet for sine of two things being added together? And if I remember correctly, the sine ones, this sine always matches the one that's in between the two terms here. Does that sound right to you? These are the tricks that I use to memorize these. So that should be a plus. If this is a plus, this is a plus. Now, if this had been a cosine, it would switch. I think cosine's opposite. So I like to set them up first. I like to set the format up first. Do you see on your pink sheets where I'm getting this from? Yeah. All right, and then I just go back and fill in my angles. So this was 2x and x, and this was 2x and x. So the instructions say I'm supposed to write this using just sines and cosines of x. Have we accomplished that at this point? No, I've got these two things that I'm going to have to take care of, the sine 2x and the cosine 2x. But, good news, we have identities for those. So we can replace the sine 2x with, we just used it a second ago. Yeah, sine 2x is 2 sine x cosine x. And we can replace the cosine 2x with, we got options. I went on with the second one this time. Going with the second one this time, and you'll see why on this. Actually, no, third one. I'm going with the third one. Going with the third one. You'll see why in a second. All right. So we could leave it like this, but this one actually simplifies. On a test, if this was your final answer and those were the instructions, you'd get full credit for it. Okay. But I just want to show you that a lot of times these will simplify pretty significantly. So if you're doing an assignment and you look at the answer in the back of the book and it doesn't match, see if you can take it a couple steps further and simplify it. So this whole term would be 2 sine x cosine squared x. Agreed? And then I'm going to distribute this sine x into here. This first part is going to be also 2 sine x cosine squared x. And then 1 times sine x is sine x. I should have left myself more room here. Do you see how we got a couple like terms we can stick together here? So if your book were doing this, they would call that 4 sine x cosine squared x minus sine x. And they would actually take it one step further. They would factor that sine x out for a final answer of sine x times 4 cosine squared x minus 1. I would say that every step from here to here is a viable answer. But I just wanted to show you, you may look it up in the back of the book, and they may have like a much simpler version. Just see if you can wrangle your expression to match what they've got. Okay, none of those is better than the others. I'd say the last one's kind of nice and neat and tidy. Now, we could not have gotten to this if we'd used either of the other two versions of cosine 2x. So if you decide to use it, like if you look in the back of the book and you're like, there's no way I can make this look like their answer, then maybe they chose a different version of that cosine 2x than you did. Okay, that doesn't mean you got to go back and do it differently. It's just yours is as simplified as it can be. All right, I will tell you that you're not going to see problems like this on the test. However, on the test, you're going to see sine 3x pop up in your proofs. And we'll practice some of those today too. Okay, so when you're actually going to be using this will be when you're doing some proofs. All right, any questions so far? So basic, just straight substitution. And that's what this next part is going to be too. We're going to talk about the half angle identities, and then we'll do a couple more examples. We'll look at one proof together and we'll be done. So should be pretty quick today. Half angle identities, we already talked about this. This plus or minus that you see on these half angle identities, this is going to be the trickiest part of this, and it's actually not too tricky today, but what we're going to do on Friday when we start solving equations, this will probably be the trickiest, most confusing part of what we do this whole unit. What I need you to know is that when we do this plus or minus, our final answer is not going to have this plus or minus in it. Okay? When we do the quadratic formula, you guys see plus or minus in quadratic formula, so you're used to it, right? You know that when you do a plus or minus in the quadratic formula, you've got to do both a plus and a minus. You're getting two answers out of this. This plus or minus is not both plus and minus. It is one or the other. One is correct and the other one is not correct. It's up to you to choose which one it is. Now, it's not that difficult because it just depends on what your angle is. So what I've got in my notes here is that this plus or minus in some of these identities, it just depends on the quadrant that your angle is in. We've already talked a whole bunch of times about, is tangent going to be positive or negative in this quadrant? You guys remember doing that? The whole all students take calculus thing? So you've already dealt with this. This isn't going to be a big deal for you. It's the same thing. You just have to remember to do it. And like anything else, I usually try and do it straight at the beginning of the problem so I don't forget to do it at the end. So I'm going to do that for this one. First thing I'm going to do is I'm going to think about the angle 15 degrees and ask myself, where is that? What quadrant is that in? 15 degrees is in quadrant 1. So what's that mean about tangent? In quadrant 1, tangent is positive. So we know our answer is going to be positive. So if I end up doing one of those identities and it's got a plus or minus, I need to choose the positive version because I know that tangent will be positive for this one. That's it. Yep. So basically, if we choose to use this version, I'm going to go with the plus version of it. Okay, now we're going to have a little jump. You might be asking yourself, why are we using this version? And I haven't talked about that yet. But yeah, if this angle had been different, like for example, if this 15 degrees had been 155 degrees, what quadrant's that in? That's 155 is in quadrant 2. Which would make, so we would use the negative version of that because tangent's negative in quadrant 2. So all you got to do is think about where's the angle that I'm dealing with, what quadrant's it in, and then is tangent, sine or cosine positive or negative there, which we've been doing that since midway through chapter 4, right? So that's the trickiest part of today. All right, let me show you how we use these half angle identities. 15 degrees is not an angle on our friendly unit circle. It's not a friendly angle, agreed? So if I ask you to find an exact value, and we now know that exact value means like something with a fraction or a radical, not a decimal answer, right? So if I ask you to find an exact value, it is not on the sheet, but that doesn't mean it doesn't exist. We can do it. We're going to leverage our half angle formulas, I'm going to try and rewrite this as the tangent of something over 2. Tangent of 30 over 2 is the same as tangent of 15, isn't it? So I'm trying to find tangent of 15. I'm rewriting it as the tangent of 30 over 2, and the reason I'm doing that is because I've got 3 different identities for the tangent of something over 2. They all involve cosine and sine of whatever that thing on the top is. I know what the sine and cosine of 30 are, so I should be able to pull this off. Question? Yes, we'll come back to that in just a minute. Absolutely, we can. I need you to be confident to do it both ways. So the question was, could we also accomplish tangent 15 using a sum or difference? And we could. What 2 angles could you subtract to get 15? 2 familiar angles. So we could do 45 and 30, and we've done that. You actually did this problem as one of your assignment problems. And the answer is going to look different than the answer we're going to get here, but it will be the same value. So good question. All right, so let's pull this off. So I'm gonna go to my sheet and we're gonna pick which one we want to do. And again, I almost always default to the middle one because it doesn't have the plus or minus, it doesn't have a square root, and the denominator is simple. So I'm gonna rewrite this as, instead of tangent of something over 2, it's 1 minus the cosine of some angle over the sine of some angle. And what's the angle that's going to go inside of that cosine and that sine here? It's the thing that was on top here, which is the 30. This is nicer because I know what the cosine of 30 is, and I know what the sine of 30 is. If you don't know what the sine and cosine of 30 are, that's fine because you got it on the back of your sheet. By the way, did I tell you guys you're going to have this pink sheet on your test? It may not be pink, and it will not have the trigonometric proof strategies on it, but everything else will be on there. Okay. So who's got these memorized? What's the cosine of 30? Root 3 over 2. And the sine of 30 is a half. And of course, we're not going to leave fractions inside of fractions like that, but we can just multiply this by a fancy 1. What would be a good fancy 1 to make those fractions go away? How about 2 over 2? Yeah. That's going to give me on the top here, 2 times 1 is 2. 2 times the fraction, bust the fraction. 2 times a half is 1. So my final answer is 2 minus root 3. Any questions there? Yes. Why is it not? Oh, why is this not 1 plus sine 30? Because that's not what it is on my identity. It's 1 minus cosine over sine. Yeah. Yep. Yes, you're right. It is in this version. Good question. Any other questions? One of the things I love about these types of problems is they are super easy to check. This is why I asked you to have your calculator out at the beginning of the period. Grab your calculator. Somebody borrowed mine, so I don't have it, but that's all. This will work. Make sure you're in degree mode. And type in the tangent of 15. Oh man, look at this. This is a fancy calculator. Does yours do that? Did it really?
Well, the ones like that do it.
Yes. Does yours do it? I don't think they do. No. No, let me put this in not fancy pants mode. Okay, sorry. Forget about that. This is the one case where these yellow calculators are a little bit more convenient than the graphing calculators. All right, so make note of that decimal. Are you guys getting 0.26-ish? Now type in 2 minus root 3. And if you're getting the exact same decimal, then you should be feeling really confident about your answer. So when you run into these problems on your test, this is kind of nice because you'll know for sure whether your answer is correct or not. It's kind of easy to make some silly mistakes on these with signs and stuff, but you'll be able to check them really easily. All right, are we feeling okay about this? So here's the taking a step back and looking at the big picture. They wanted us to find a tangent of an angle we don't know. I'm like, I don't know 15, but I know something that divides by 2 to give me 15. So I'm going to rewrite this. I'm going to use my identity. Since this thing that I put on the top of the fraction here is one of those numbers that I know, one of those friendly angles, I'm going to be able to pull this off and get exact values for this. And then we just had to do a little cleanup at the end. All right, let's do another one. We'll end up doing 3 of these altogether. Cosine of 255. 255, I do not know that angle. That's not one of my 16 points. So my options are, I could either find 2 angles that I do know that add up to 255. 210 and 45 would work. So we could use an angle sum formula. Is 255 coterminal to something? Well, it's coterminal to a lot of different things, but the question is, are any of those things are familiar angles? I'd say no. If I wanted to try and write this as something over 2, what would that thing on the top be? What do you divide by 2 to get 255? 510? Now, let's ask that question again. Is 510 coterminal to something? 510 is coterminal to what? 510 is 360 plus 150. Okay, so we should be able to pull this off because we're going to be able to think of this 510 as being coterminal to 150. So let's go ahead and do this. So we'll get to that in a second. Just trust that this is going to work. So 510 is going to work for us because I know that it's coterminal with 150, and I know 150. I know some stuff about 150. Now cosine, this is one of those ones with the plus or minus, right? It's plus or minus. I don't have these memorized again yet. Inside of the radical, we've got 1 plus cosine of something over 2. That's right. Now, before I go any further, I want to figure out, is it the plus or is it the minus? Is it the plus or is it the minus? And to figure that out, I need to look at my original angle, the original problem that I'm dealing with. Is the cosine of 255 going to be positive or negative? What quadrant is 255 in? 255, that's bigger than 180, smaller than 270. That's quadrant 3, and in quadrant 3, cosine is negative. Ooh, spring break. We lost some stuff, didn't we? Okay. Well, our answer is going to be negative. Yeah, it's a tough transition coming back. How many people, for how many of you is this statement a true statement? This morning is the first time I woke up to an alarm in the last 9 days, 10 days. I'll own it too. Same. It's tough. Every time I'm like, yeah, maybe those last couple days before break ends, I'll get back on this schedule, and then it never happens. All right. Okay, let's keep it going here, guys. What number is going to go in this cosine? I'm going to put the 510 up here for my notes, but I would normally put 150, and then I would do the next. So let's put 510 in here because it's always the thing on the top of our fraction. And then in my next step, I'm going to go ahead and change that because the cosine of 150 is the same, or sorry, the cosine of 510 is the same as the cosine of 150. Agreed? We learned that like very first thing in chapter 4. Why do they have the same value of cosine? Because they are coterminal angles. Coterminal angles are angles that are multiples of 360 apart. All right. I need to give you a big warning while we're here. Folks, if you want full credit on your assignments, excuse me, can you please stop? Thank you. If you want full credit on your assignments, it is important that I can tell whether, if you got a fraction inside of a radical, I need to be able to tell whether the entire fraction's inside of the radical or just the numerator. And if I can't tell clearly, I'm going to assume that it's incorrect, and you'll be losing points. So if you need to exaggerate that radical, bless you, so that I know for certain that that 2 is a part of it, just make sure I can tell. Okay, if I have to stop and guess, I'm just going to take off points. You make it clear to me. It's your job to communicate clearly. All right, let's finish this off then. So this is, the minus is staying. My big old square root's staying. I'm going to make it huge this time. And I've got 1 plus and cosine 150. I'll just leave a blank where the cosine 150 is because I know what the cosine of 150 is. Do you? It's negative something. Negative reference angle is 30 degrees and cosine 30 is root 3 over 2. And then I just need to clean this up. So we got all kinds of mess going on here. We got fractions inside of fractions and radicals inside of radicals. Got some good news for you. I don't have trouble with radicals inside of radicals. Fractions inside of fractions we're going to fix though. So give me a nice, convenient, fancy one that we can use here to make this a little neater. 2 over 2. I think that sounds good. So again, make sure it's clear to me whether the entire fraction's inside the radical or just a piece of it. You'll see some 4 over 4s also. Is that true? Maybe. No, I think you're right. Tangent, you'll have some, with tangents you can end up with root 3 over 3, so you might have some 3 over 3s, yes, mostly 2 over 2s. Hey, did you know that when you've got a fraction inside of a radical, you can take the square root of the top and bottom separately? We should probably do that since we know the square root of 4, right? So my final answer is still going to be negative. This time I'm only going to have a square root in the top, and I'm going to exaggerate that fraction bar so that whoever's reading this knows that that square root is only in the top. This should be a this should be a 2. I've got a mistake here. This should be a 2 here, and here, and here. Thank you. Was that what you were going to ask me? Yeah, thank you. Not in the first one, yes. This should be a 1. I forgot to multiply my 1 by the 2. Classic mistake. 2 times 1 is 2, not 1. The question a moment ago was, are we okay with square roots inside of square roots? I'm fine with that. If you end up with a fraction inside of a square root, in this section, I'm not going to make a big deal about that. Some teachers will. A lot of times you're going to end up being able to take the square root on the bottom anyways, though.
Are you allowed to have a root inside of another root?
Yes, you can. If you look this question up in the back of the textbook, I don't think this is on the exact of any of the homework assignments. This is the way the textbook would write it, though, just so you're prepared for this. I'm thinking they write it that way just to eliminate any hesitation about whether the square root is only in the top or covers the bottom as well. Like this way we know for sure that there is no square root in the denominator. So either of those is fine though. All right, one more. 11 pi over 12. It's not on our circle. There's nothing over 12 on our circle. So if I want an exact answer, I'm either going to need to find two angles that add up to 11 pi over 12, and that can be done. We actually did that in our assignment before spring break. But let's try to do it with half angle formulas. So I'm trying to rewrite this as the sine of something over 2. But when it comes to problems that are in radians, it's actually more convenient to rewrite it as the sine of 1/2 times something. Because something over 2 is the same as a half times something, agreed? Yep. So I'm trying to get 11 pi over 12. What am I going to have in this spot here? 11 pi times 1 is 11 pi, and then you want to put a 6 down there? 2 times 6 is 12. Yeah, those are the same, aren't they? So we're in radians and we're dealing with fractions. Usually instead of trying to write it over 2, I'll write it as a half times something. All right, so let's do our sine. This one is sine, oh, not sine. It's a big old square root with a plus or minus in front. We'll have to deal with the plus or minus at this point because I forgot to before. And I know it's a 2, and I know there's a cosine. Is it 1 minus cosine, or is it cosine minus 1? 1 minus cosine. I had to look at my cheat sheet. And what am I going to put inside that cosine? 11 pi over 6. And are we okay with this? Do we know the cosine of 11 pi over 6? Yeah, we know our over 6s. Those are on our wheel of fun. And if we don't know it, we'll be able to look it up. Before we do, though, let's think about whether it's a plus or a minus. So 11 pi over 12, that's less than pi, right? Not much. It's really close to pi, but it's less than pi. So quadrant 2. And is sign positive or negative in quadrant 2? Sign's positive in quadrant 2. So we're going to use the positive version of this one. So we're doing a positive, leaving the negative out. Cosine of 11 pi over 6, that's 30 degrees off of 360. It's going to be positive. Cosine of 30 degrees is root 3 over 2. I think it's root 3 over 2. Can someone look at their wheel of fun and confirm that? The cosine of 11 pi over 6? Yes? All right. Getting it back. Every year when we start memorizing the sines and cosines and tangent, it gets a little bit easier for me to remember it. All right, clean it up. Fancy version of 1, what's going to be helpful to us this time? 2 over 2 again. So we've got 2 times 2 is 2, minus that times 2 is just going to cancel my denominator. 2 times 2 is 4. Did I just say 2 times 2 is 2? 2 times 1 is 2. 2 times 2 is 4. We're good there. I'm pretty sure it's root 3 over 2, but let's double check. Cosine of 11 pi over 6. Here's 11 pi over 6, and cosine would be the x value. It is root 3 over 2. It's all right. It's good to guess and then check. That's how you learn. That's how I learn anyways. Flashcards. Anybody find a good Quizlet for these yet? Yeah, if anybody does, send me a link. You might get an extra bonus point if you give me a good link to a Quizlet I can put on Canvas. I think this can be cleaned up also because we know what the square root of 4 is. So let's write our final answer here. My square root is going to clearly just be on the top. I'll exaggerate that fraction bar just to make sure there's no doubt in anybody's mind. We'll go with that. We didn't check the last one, but I want to check this one, so I need to make sure I'm in radian mode this time. I'm going to type in the sine of 11 pi over 12 first. And then I'm going to type in my fun little answer here. Got to be careful with your parentheses. 2 minus square root 3. I need to end the parenthesis on the square root 3 and then end the big parenthesis also before I divide by 2. Check your parentheses. Oh, that's it. That's it. Those buttons are right next to each other. They're easy to... I'm getting the same answer for my original problem and our final answer. The same approximation for both. Feeling good. Check your parentheses. Did you close both parentheses? Are you in radian mode? Ah, that's it. Yeah, because 12 pi over, or 11 pi over 12 is radians. All right, our last one's a proof. Last problem's a proof. I would love for you to try this out. If you're not sure what to do, here's a giant hint for you. Look at one of the examples that we did towards the beginning of class. Oh, by the way, I'll give you the biggest hint. Remember how I told you always want to start on the most complicated side? All right, I can tell you from experience that when you're multiplying or dividing your x inside of a sine or cosine, that's the most complicated side. Start there. Start on this cosine 3x side, for sure. This is kind of a big old mess over here, but this is more complicated. All right, give it a shot. I'm going to put a helpful hint on the screen, but if you're trying to do this on your own, just resist the urge to look up here. If you're totally stuck and you're not sure after you think about it for a little bit what to do next, have a peek up here. See what you can do. I'm not going to put my, I'm not going to walk you through this. I'll put my final proof up here in a moment, but I want you guys to have an opportunity to try this out. Ask me for hints, ask your neighbors for hints, spy on your neighbors. We don't have any identities for cosine 3x, but we've got identities for 2x and x. So that's an angle sum formula. I'm adding two angles together. It's cosine, so that's cosine, cosine. Oops, I need some space for my angles. Cosine, cosine, and sine, sine. And I can't remember, is it the opposite for cosine? If it's a plus here, then we put a minus here? That's what I was thinking. Actually, somebody came up with this second period today. They said it actually spells out cosine. Cosine opposite. So here's the C, here's the O for opposite, and here's the S. So cosine spells cosine. I thought that was a pretty clever little trick. I'll probably remember that next year. So if this had been a minus, this would be a plus. C opposite S. I liked it. 2x and x, 2x and x. And the trickiest part of this problem for me was to decide which of my three versions of cosine 2x to use here. And I looked up here to give me the answer. I picked the one that looks the most like the thing I'm trying to get, this 1 minus 4 sine squared x. It's not exactly that, but there's one that looks a lot like 1 minus 4 sine squared x. That's the one I used to replace this cosine 2x. Sine 2x, there's only one option. See what you can do from there. I'm going to keep checking some assignments.